Hey everybody, it's Miss Smith. So today I really just wanted to take some time and really just kind of slow down and really get into what you're gonna see on the exam next week. So I know that some of you are struggling. I've talked to a couple of you, and there's certain concepts you're struggling with. And after grading some of your quizzes, I realized that there's quite a few of you that are not doing so hot, or you're having issues. So what I want you to do with this video is because I'm working some fairly complex problems, but the steps are still the same. You're still going to find net force, you're still going to find frictional force, all of those things. So what I want you to do is I'm going to work them all out. I think I've got 4 total that I'm going to work out. But I want you to, once I give you the question, I want you to try it, write down the question, pause the video, and I want you to try it. Just like how we did in chemistry, when I would say, okay, here I work 2 problems, and then we work 2 problems together, and then you would try a question while I did it on the board, and I wouldn't walk you through it. And so it's the same kind of thing. I'm going to work it out, but what I want you to do is, before I work it out, I want you to pause the video and see if you can figure it out without me helping you along the way. And then you can check yourself when I do it. Now, if you're struggling and you're having issues and you need a little help, you need a little hint, then play a little bit of the video and then pause it and see if you can get it from there. And then if you still need some more help, then play some more of the video and then pause it and see if you can get it from there. So I'm trying to teach you guys how to help yourselves learn difficult concepts, because this is one of the most difficult concepts of the entire year. So you need to make sure that you're trying your best and that you are self-assessing. Do you really know what you need, what you know, and do you really know what you don't know, and things like that. So what do you know and what you don't know? So if you can evaluate yourself and say, okay, I don't understand this, then what you can do is you can come to me and say, Miss Smith, I need some help. And I can do that. Not a problem. Okay? Not a problem at all. But again, you're not in front of me, so I can't tell. So you've got to be the one to figure out, do you really understand it? Do you not? Okay, so I'm trying to help you with that. All right, so I'm going to go into my notebook. And I've got a couple of problems here. So this is the first one. It says 562 Newton truck slides down a frictionless plane inclined at an angle of 30 degrees from the horizontal. A, find the acceleration of the trunk, and B, find the acceleration of the trunk if the coefficient of friction was 30. So we're actually going to cut off this section real quick. Let me crop this real quick. So we're just going to do A. So I wanted to do one with friction and without friction. So we're just going to find the acceleration of the trunk. Okay. So the first thing that we need to do, anytime that we've given, well, let's go ahead. So go ahead and write this question down. I want you to go ahead and pause the video, see if you can figure this out. Remember, you need to start with your free body diagram. There's your little hint to get you started. So go ahead and pause and work it out. All right, so we're going to start with a free body diagram. Let's see if I can draw a triangle today. Maybe, maybe not. That's kind of small. Ah, look at there. Okay. So let's say that we've got this trunk on an inclined plane. Okay, so we've got, let's do the free body diagram. We have gravity that's straight down, that's Fg. We then have normal force because this trunk is sitting on a surface and that's perpendicular to your surface. Now, straight back from normal force, because remember normal force and Fg of y are in the same direction. Well, not direction, but, kind of almost parallel to each other. Anyway, okay, and then you're going to come in and do your x like this. That's Fg of x. Now, I did talk with a student earlier this week. If you're having, arrows that overlap like this, that's fine. I'm really looking that you have a 90-degree angle between x and y, because if you have this 90-degree angle here, then that means that this angle is correct. So, and let's go ahead, this angle is 30 degrees, which also means this angle is 30 degrees. Okay. Now that I've labeled that, let's go back and let's do the other, see if we've got anything else that needs to go on this free body diagram. It says I got a truck sliding down a frictionless plane with an angle of 30 degrees. Okay, so I don't have an applied force. It doesn't say that the truck, oh, it says truck once and then trunk. Okay, anyway, we're just going to go with truck. Anyway, so what we're going to do is we'll say, the question doesn't say the truck is being pushed or something like that. It actually just says that the truck is sliding. So it's not that the truck is accelerating like it was the gas pedal is pushing, you push the gas pedal down and the truck's accelerating itself down the incline. It says that the truck is sliding down the incline. So there's no applied force at all. Now, I don't have friction, so I don't have to worry about that. So really the only thing left is net force. Now you are going to have a net force because the truck's moving. And then that's it. So you've got net force going down the incline because it says that it's sliding down. And then the only thing you do after that is you got to remember to bring your x. Your x is right here. You got to remember to bring your x up. So I'm going to do a little arrow. Oh. Do a little arrow F. G of x. And that's it. So from here, the easiest thing to do from here is to write your net force equation. So you've got to look at everything that's going on here. That's most of what's going on, okay? So technically all of this right here equals this, okay? So these kind of cancel each other out. You are going to deal with x a little bit, but this one, those are kind of null and void. It's this one you've got to really concern yourself with. This only comes into play when you're dealing with friction because remember, friction depends upon how hard you're pushing on a surface, which is what this measures anyway, what FG I just labeled both of those FG of x. That's FG of y. Okay. Anyway, so really you don't need to worry about this here. You don't need to worry about that. And you don't need to worry about this because that's only for friction. So it's really this one. So these two are null and void. This one here is important. Now, these two kind of cancel out this one. So the only one you've got to worry about is this one. And we already pulled it up here anyway. So they are headed in the same direction. Now, I don't have anything acting against the net force. Now, net force is overall what's happening. So the only force that's actually acting on this box in the first place is FG of x. So that means that my net force is equal to FG of x. And that's it. So all you do now is you calculate FG of x. FG of x is equal to mass times gravity sine of theta. So FG of x is mass times gravity. Now, this was given to us as 562 newtons. That means that that's already mass times gravity. Had it say 562 kilograms, then that's not mass times gravity, that's just mass. Because it's in kilograms, so you've got to pay attention to your unit. So this is a newton, so that means that's already mass times gravity. Okay, so I'm going to go ahead and put 562 in there. We're going to do sine of our angle, sine of 30. Where is my calculator? There it is. All right, so we're going to do, I forgot already, 562 sine of 30. Let's check to make sure that our calculator is in degrees. Yes, it is. So 562 sine of 30. And that gives us, I'm going to round to a whole number. Oh, it is a whole number. Look at there. 281. And that is in newtons, 281 newtons. Now, I'm not worried about you putting a direction yet. I'm only really looking for direction when you do your final answer. So let's see if we finish the question. It says final acceleration. Well, that's not acceleration. But we know that the equation for acceleration is F net over the mass. So I can figure out F net because FG of x is equal to F net. So I can do that. So 281 newtons now divided by the mass. Now I don't have a mass. I do have this one up here, which is m times g, which is technically the weight. So 562 is equal to, let's see, mass times gravity. Let's rearrange this a little bit. We are solving for mass, which is going to be weight divided by gravity. So 562 divided by 9.8. Let's just say 57. So mass is 57 kilograms. Okay, so you do 281 divided by 57. And let's just round it to 5. So 5 meters per second squared down the incline. All right, and then so this is your final answer. This is what I look for. You have the magnitude, you have the unit, and you have a direction. So if we were doing this, a paper-based test, and you were sitting in my classroom, this question would be 20-ish points. So I'm fixing to identify where all of these points would come from. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and I think I just give you a 10 for trying this whole thing. Okay, so that free body diagram is about 10 points every single time when I have you draw a free body diagram. So you would get a point for doing this. So this would be 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So about 20 points. Okay, sometimes you get a point for just writing this. All right, I give you a point for doing this. All right, so that's if we were, meeting in person. Not 100% sure how I'm going to do your test yet. I think a lot of your questions are going to be not necessarily calculations, but, understanding this. Maybe, I don't know. We'll see. We'll see what I come up with. I don't know yet. That's not till next week. Okay, so that's the end of that question. Let's move on to the next one. Okay. A 24 kilogram crate initially rests on a horizontal floor requiring 75 newtons horizontal force to set it in motion. Find the coefficient of static friction between the crate and the floor. Okay, this one is not on an inclined plane. It is flat. And this involves the formula for friction. So go ahead and pause the video and see if you can figure this out. So frictional force is equal to, so Fg of y times the coefficient of kinetic friction. So if I rearrange this formula to find the coefficient of kinetic friction, then that gives me frictional force divided by Fg of y. All right, so this is the formula that we're used to seeing. Here's the problem with this formula. This is on a horizontal plane. We're not dealing with this on an inclined plane. This is written for an inclined plane. So this formula doesn't necessarily work. Also, this is for the coefficient of kinetic friction. We need the coefficient of static friction. All right, so let's go ahead and draw a free body diagram just so we can figure this formula out. So here's my crate. Acting downward is gravity, okay? Of course, acting upward, equal but opposite, is normal force. And it says that I have a horizontal force of 75 newtons to set it into motion. Now, this is your applied force. When you have static friction, okay, and you just begin to move, your frictional force will be equal to your applied force. And so that's how this is worded, is it says 75 newtons to get it to move, to set it into motion. So at that very second that it starts to move, it took 75 newtons to do that. And at that very second, your frictional force will be equal to your applied force. Now, let's say that this was an inclined plane, your frictional force would not be equal just because it would be on an inclined plane instead. But since these are flat and they are in opposite directions, they are equal to each other. So let's rewrite this to match for coefficient of static friction. Now, friction depends upon two things: the type of surface which is normally signified of coefficient of kinetic friction. We're dealing with static friction. Okay, close enough. And it also depends upon the force on the surface. Okay, and so this time we're going to say Fg. Normally it's Fg of y because it is what's pushing on the surface. But this time the only thing acting downward is force of gravity. So we're going to rewrite this formula for coefficient of static friction, and that's going to be the frictional force divided by the gravitational force. So the frictional force was 75 divided by 24 times 9.8, because remember Fg is m times g, so mass times gravity. So that's going to be 24 times 9.8, 235.2, 75 divided by that answer, 0.32. Now remember, your coefficient of static friction or kinetic friction or whatever it may be will always be under 1. And this is your answer. That's it. Done. All right, next question. A crate is pulled to the right with a force of 82 newtons, to the left with a force of 115, upward with a force of 565 newtons, and a downward force of 236 newtons. Find the magnitude of direction in terms of an angle of the net force on the crate. Okay, so this one is reviewing ultimately free body diagrams and x and y components of vectors. Okay, so we're going to take some of your knowledge that I've been teaching you and applying several different concepts all in one. Okay, now I know you're like, Miss Smith, I need to know one of those ones that we did on Monday. I need help with that. Okay, that's the last problem I'm going to do. So I wanted to give you some different scenarios, some different questions. Now, if I'm not making any kind of sense and you want me to go over this when we do the Zoom call tomorrow, fine, I'll do it again. Okay, just let me know what you want me to do. Okay, so first things first, anytime you're doing any kind of these problems is draw a free body diagram. Now this time we have values for these. So we have straight down. So straight down was 236. To the right was 82. Left was 115. And upward was 565. Okay, and these are all in newtons. So my first instinct is I want to know this, what's left over going this way. Okay, so we're going to do 565 minus 236. Now, because this one is way more than this one, we know that that direction will be upward. So 565 minus, so I'm just going to do this on my calculator, very simple. 565 minus 236 is 329. Oh, my Apple Pen is not wanting to work today. Goodness. 529 newtons. Okay, and this is upward. Direction matters on this one, so I'm trying to keep myself sane here. Okay, so now I want to do the same thing this direction. I want to see which direction is more. So this one's going to be more. The 115 will be more, so I know it's going to be to the left. And I'm going to subtract 115 minus 82. That is 33 newtons left. Okay, so basically this are the x and y components of a vector. Now, because you know that this is a 90-degree angle, okay, oh, I just erased stuff. You know that this is a 90-degree angle, so your brain is already telling you, Pythagorean theorem, Pythagorean theorem. Yes, you could, that's fine, because you don't have an angle yet. I mean, yeah, I know this is 90 degrees, but you don't have this angle or this angle. What you're trying to find is the resultant vector. Okay, so let's go this real quick. We'll go ahead and do Pythagorean theorem. Okay, so I need to find, so this is technically in your y direction, and this is your x direction. So we're going to do 329 squared plus 33 squared is equal to, so this is Pythagorean theorem. Let's do 329 squared plus 33 squared. Hit enter. Second answer. Let's just say 331. Now, that is your resultant vector. So the answer is 331 newtons. But here's the problem. What direction? Okay? I mean, yeah, you could say it's probably going this way. Yeah, probably. Okay, but it says find the magnitude. We found the magnitude, that's this. But we need a direction in terms of an angle. An angle. All right, so that means we need to use, I'm going to use tangent, and I'll tell you why in just a second. So let me erase something real quick. I'm going to use tangent, okay? This is a 90-degree angle, so I'm going to use sine, cosine, or tangent, and I'm going to choose this one you want to use. So here's why I chose tangent. Okay, so let's draw this. So let's say that we take both of these values and we draw a little triangle. Okay, so I know it's 329 upward and 33 to the left. Your goal, well, let me do it like this. Your goal is to find this vector here. That's the goal. That's what you need to find. It's this one. Okay. Now, I know it looks a little crazy. All right. So I'm going to redraw this. So 329 upward, and then 33 newtons to the left. Oh, that's to the right. To the left. Okay. So then you're looking for this one here. That's better. Okay. You always need to draw your vectors from head to tail. That was my problem. That's what I did the first time. So you always draw your vectors from head to tail like this, and the resultant vector doesn't really matter. Okay. So that kind of matches what we said here. Yeah, it should be this direction. Yeah, sure. But you need to find this angle. I need to know how far over it is. Okay. So what you do is you use this one and this one to solve for this angle here. Because this, 329 upward, is technically the adjacent side. And this is the opposite side over here. So tangent of an angle is equal to opposite over adjacent. Okay, so remember SOHCAHTOA. I actually had to say it in my head, so I told you the right one. SOHCAHTOA, this is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's how I remembered that it was opposite over adjacent. So let's go ahead and we're going to do tangent of the angle is equal to opposite, which is going to be this little short one here, which is 33, over the adjacent, which is this one here. It's going to be 329. Now, I need to get theta by itself, so I divide both sides by tangent. So this becomes, I'm running out of room here. Erase this. This becomes theta is equal to inverse tangent 33 over 329. So here's how you put that in the calculator. Anytime that you're trying to find an angle, you have to use the inverse function. If you're trying to find a side, then you use a regular function. Okay, but let's go ahead and let's put this in the calculator. Second, tangent 33 divided by 329, close, enter. 5.7, so let's just say 6. 6 degrees. So let's say 331 newtons at 6 degrees from the horizontal. No, excuse me, from the vertical. Okay, so that's this one here, the 6 degrees there. From the vertical, it's going to be how far over you are. Okay, so that's going to be from the vertical. All right. I know that this question is probably super bizarre and you're like, we did not learn this. Okay, again, this is application of knowledge. This is taking several concepts that we've been learning and applying your knowledge to it. So if you need me to go over this one again, just let me know. I can. Okay. Last one. If Rachel is pushing a box of rocks 560 newtons up a loading dock with an incline of 21 degrees, what is the acceleration of the box of rocks? The mu sub k is 0.22. She applies a 675 newton force to the box. Okay, first things first, free body diagram. So let's draw a triangle. Okay, so she's pushing a box of rocks here. And we're going to go straight down with gravity. Perpendicular to our surface is normal force. Straight back from normal force is Fg of y. 90-degree angle with that is Fg of x. This is Fg. Okay, this angle is 21 degrees, so that means this angle is also 21 degrees. Okay. So the first thing that I like to do when I do this one is I still need to go ahead and figure out net force. So she said she's pushing a box of rocks up the loading dock. So that means that I have an applied force up the incline. I do have friction because it lists a mu sub k right here. Lists a mu sub k, so I do have friction. So that means I'm at a little bit going down. Since she's pushing up, it's going to go down. I still have my Fg of x here, also going down. So that means that our net force, we can go ahead and draw a net force. I'm going to do this in a different color. Net force is going up the incline. Okay. Now, let's go ahead and do a calculation for the net force. Net force is equal to applied force minus frictional force minus Fg of x. All right, so some of these I know. Net force, see the applied force, she applied a force of 675 newtons. Minus the frictional force, we got to figure that one out. Minus the Fg of x, we got to figure that one out too. Okay, so I'm going to do Fg of x. I'm going to do Fg of x in yellow. So Fg of x is equal to mg sine of theta. Fg of x. So mg is just the box of rock weighs 560 newtons, so it's going to be 560 sine of 21. 560 sine of 21, rather than there's whole number 201 newtons. Okay, so that goes there, 201 minus Ff. So Ff is frictional force, so I'm going to do this in a different color. Frictional force is equal to Fg of y times the mu sub k. Frictional force is, we got to find Fg of y before we do mu sub k. Mu sub k is already there, it's 0.22, but I've got to find Fg of y, so I'm going to come down here in black and find Fg of y. Fg of y, not x, y is mass times gravity cosine of theta. 560 cosine of 21. $523. Okay. So I'm going to go into here, 523. So 523 times 0.22, 115, say 115. So 115. So now you just put this in a calculator, 675 minus 115 minus, forgot, 201. 359. So F net is equal to 359 newtons. Now, let's go back to the question and see what we got to figure out. It wants us to do, what is the acceleration of the box of rocks? What's the acceleration? Okay. So we just found net force is all we found. So now we've got to go and do acceleration. Okay, well, acceleration is F net divided by the mass. Well, I know F net, I already got that one. That one's right there. Acceleration is 359 divided by the mass. Well, mass is not provided in our question, but we do have this 560 newtons. 560 newtons divided by gravity. So 560 divided by 9.8 is, 560 divided by 9.8. 57-ish. So then we just do 359 divided by 57, and we get 6.3. So let's just say 6 meters per second squared. Direction up the incline. Okay, and that's it. All right. Let me know if you have any questions. Tomorrow, please make a list of things that you're supposed to be working on today. Go back. I listed all the answers to all the problems that we have been doing for the last several days. So go back and check your work. If you got anything wrong, write it down. So tomorrow, when we do the Zoom call tomorrow, you will have something to ask me. Everybody must have something to ask me on Thursday in the Zoom call. Everyone. All right. Have a good day.